We're going to be looking at Unit 6 review for the Term 2 final for probability and statistics. Unlike Unit 5, which was our and probabilities that dealt with multiplication, Unit 6 was our or probabilities that dealt with addition. So starting off, it says, for problems 1 through 4, you conduct a survey that asks 600 students at your school about whether they prefer pizza or chicken nuggets for school lunch. 389 juniors respond, 195 of which prefer pizza. 72 seniors prefer chicken nuggets. So I know our two categories are students, juniors and seniors, and then food, chicken nuggets or pizza. So on the side, I'll just do P for pizza, chicken nugget, total. Then I have junior, senior, and total. And we did do a problem like this on the Unit 5 portion of the review, but let's do it again. Reading through, I see we have 600 total students. And then it says 389 juniors respond. So juniors, 389. 195 of which prefer pizza. And then 72 seniors prefer chicken nuggets. Okay. Just like before, we're going to fill in the rest, either by adding or subtracting. So, to get the total seniors, we're going to take the 600 minus the 389, and we'll get 211. To get the juniors that prefer chicken nuggets, we'll do the 389 minus the 195 to get 194. To get the seniors who prefer pizza, we'll take the 211 minus 72, get 139. And we'll add across to get our total. So 195 plus 139 gets us 334. And 194 plus 72 gives us 266. Question 2 says, what is the probability of a student being a senior or preferring pizza? So probability of a senior, well, we have 211 seniors out of the 600. Or once again, we have to add. Then the probability of preferring pizza, well, there were 334 people that preferred pizza out of the 600. But then we need to see, are these mutually exclusive? Do we have an overlap? In other words, in this problem, do we have seniors that prefer pizza? Which we do. We have 139 of them, so we need to subtract that overlap. Minus 139 out of 600. As a quick reminder, to add or subtract fractions, the denominator or the bottom has to be the same, and we just add or subtract the top. So I know it's going to be out of 600. And 211 plus 334 minus 139 gives us 406. Once again, I'm going to leave my answer as a fraction. Question 3. What is the probability of a student preferring chicken nuggets or are a senior? Well, chicken nuggets, there were 266 out of the 600 that preferred chicken nuggets. Right, add because it's an or. There were 211 seniors out of the 600. And once again, we need to see if they are mutually exclusive to see if there is an overlap. And there are seniors that prefer chicken nuggets. So there were 72 of them, so we need to subtract 72 out of the 600. Once again, denominator is still going to be the 600. And then 266 plus 211 minus 72 gets us 405. Question 4 is asking, are the probabilities in questions 2 and 3 mutually exclusive? In other words, did we have to subtract? So no, these are not mutually exclusive because you can think of it as there is an overlap or we had to subtract. For questions 5 through 6, in the results of the survey, probability of A equals 43%, probability of B equals 60%, and the probability of A and B equals 21%. Question 5 says, what is the probability of A or B? So we need to take probability of A, which is the 43%, plus the probability of B, minus the overlap or the probability of A and B. And we should get 82%. Question 6 is saying if probability of A is owning a car and probability of B is owning a pet, interpret your answer for question 18. On the final, the word interpret will not be bolded or underlined, but that is a key in this. Interpret always means use words to describe. It's supposed to be actually question 5. So, in words, we would end up saying then 82% of people have a pet or a car. Or is the key word in this problem. Okay. Once again, like in the Unit 5 review, the top bit is a blurb about what is in a deck of cards. If you need to read through those real quick, go ahead and take a pause, read it, and then resume. Question 7 says, you choose one card at random from the shuffled deck. The probability that you choose a red card or a 2. Well, reading above, I know that there are 26 red cards out of the 52. And then drawing a 2, I know that there are 4 2s in the deck of 52. But once again, I need to think, do we have any 2s that are red? Well, since we have a 2 in each suit, heart, club, spade, diamond, 2 of those suits are red, so I need to subtract 2 out of 52. So I know my bottom is going to be 52. And 26 plus 4 minus 2 is 28. Question 8. You choose one card at random from the shuffle deck. Find the probability that you choose a heart or a club. Reading above, I know each suit has 13 cards in it. So, probability of red would be 13, or heart would be 13 out of 52. Plus probability of a club would be 13 out of 52. And we need to stop and think and see, do we have a card that is both? Can we have a card that is both in the hearts and in the clubs? And we can't have a card that is both a heart and a club. So this one would be mutually exclusive, so we're just going to add. Adding, we would get 26 out of 52. Question 9. You choose one card at random from the shuffle deck. Find the probability that you choose a spade or a king. Well, I know there are 13 spades out of the 52. And I know that there are 4 kings in a deck out of the 52. But then once again, stop and pause and see, do we have a overlap? Can we have a king that is a spade? Well, each suit has a king, so we need to subtract 1 king out of the 52. Adding across, we'll get 16 out of 52. Question 10. Is the event drawing a diamond and the event drawing a 10 mutually exclusive? So, knowing we have each type of card in each suit, I know that there is a 10 that is a diamond. So, no, these are not mutually exclusive because there is a 10 that is a diamond.